Everyone, and welcome to this video about the fundamentals of the fuses that is used basically to protect the distribution system. I will talk about the basic fundamentals of the fuse, how it works, what are the ratings of those fuses, and then I will end up my presentation by a simple demonstration to simulate to you the two functionalities of the fuse. Now, in a previous video, I showed to you the cutout fuse that protect the transformers, and we said that part of this cutout is that fuse. This is the fuse. So when I see what are the ratings, what is inside that fuse, so basically here you have a link. So the current will be going here, going there, and these small segments are places where you will have a high density of currents, and hence if the current exceeds certain values, they will start to melt. And inside here, there is also fill-ups. Now, why we use the fuse? For two things: for overload. Once the current exceeds certain value, to protect the equipment, protect the cables, the fuse will melt to interrupt the power. Also, whenever there is a short circuit, when there is a fault in the system, also the fuse will interrupt. However, the time it will take the fuse to interrupt an overload is different than the time it will take to interrupt a short circuit. We'll see that. Now, what are the important parameters when you go and buy a fuse? You have to understand them. First, the continuous current rating. This fuse will be inserted in a system. You don't want the fuse to interrupt the normal current. So you have to know what is the continuous current rating. What is the current that the fuse can carry without any melting? Second point is that once you exceed that current, then the fuse will start to melt. Question is, what is the maximum current the fuse can interrupt without any problem? So this is called the interrupting current rating. It is the largest current that the fuse can safely interrupt. Now, once the fuse interrupt the current, once we have an open circuit in the fuse, there will be a voltage between this open circuit, and here comes to the voltage rating. What is the voltage that the fuse can withstand after it interrupts the circuit without reigniting the arc inside the fuse? And this is called the voltage rating. Now, this is basically a typical time response, which is something very, very important in the fuses, the time response for a 15.5 kV, 100 amp fuse. Now let's understand this. The 15.5 kV, this is the voltage rating. So that fuse is suitable to be installed in a 15.5 kV system. The 100 amps, it means that the fuse can carry such a current 24/7 without melting, without even starting of the melting. Now, when you look to this, the time response, this is the inverse time current characteristic. It's very important characteristic of the fuse. So in the x-axis, we see the current values. In the y-axis, we see the time it will take the fuse to start the melting, and then total clearing time, the time that it will take to totally clear the fault. Now, if the current is 100 amps, it will never intersect with these two curves. It means that the fuse will neither start melting, nor it will, of course, it will not interrupt, or it will not be clear that current. So it's designed to handle this current 24/7. Now, let's see what will happen if we start to have, let's say, an overload. So what will happen if the current, for example, reach 500 amps? So if it reaches 500 amps here, it will take around 2 seconds for the fuse to start the melting process. Okay, but this melting process is not instantaneous. It will take some time until, so at 5 seconds here, the fuse will be completely an open circuit. So it will take total of 5 seconds for the fuse to clear that this what could be an overload. However, when we have an extremely very high current like this one, 5,000 amps here, so it's extremely high, you will have a fraction of a millisecond, 0.1 millisecond, to clear that fault in a in just a fraction of a millisecond. Why? Because in the fault, the system has to act almost instantaneously. And you can see that once the current becomes very high, the response time of the fuse is extremely fast. Now, let's go and let's share my screen again, sorry. And let's basically go and do some sort of simulation. So I arrange this simulation for you. And here basically I have 3 loads and I have a fuse here and we have a supply. The supply is giving me 120 volt. There is an ammeter here to measure the current and the fuse says 32 amps. 32 amps, this is the current rating. So the fuse can handle such current 24/7 forever without any problem. Let me double click on the fuse and see the inverse current time characteristic here to understand for that specific fuse how long it will take to clear an overload. So when you look here, so this is the current and here is the time. So if we reach around 100 amps, it will take 30 seconds almost to clear. Of course, when it reaches 32, it will never intersect, so it will stay forever here. Now, when it reaches here around 150 amps, it will take 13 seconds. So if I design it to have it around 120, 25 amps, so it will take around 20 seconds to clear to create this overload. So here we have these 3 loads connected in parallel. So we'll increase the load and see what will happen. And then here, this is a short circuit. So we'll see what is the response time for the fuse to interrupt such a short circuit. So let me start here. Let me close the switch of the supply. So we have no current at all. Okay, now let me connect the first load. So the first load drives around 32 amps. Okay, down here is the time. Now, if I leave this running forever, the fuse will never interrupt. Okay, now when I add this load, now I have an overload. 80 amps, it will take more than 30 seconds. To expedite the process, I added another overload here. So we have around 129, 130 amps. So it will take around 20 milliseconds for the fuse to interrupt this. So if you watch the time here at the bottom, now, okay, see the fuse has interrupted and opened, but it took some time before it acts. Let me now disconnect this and let me run it again. And let me run here the system. And now I will connect the short circuit. See what will happen when I connect a short circuit. The fuse immediately interrupts. And this is the second functionality of the fuse, which is to protect it from the short circuit. So this is basically a very short description of the fuse, its functionality, its rating, and a simple simulation to show all of this.